Good day, ladies and gentlemen. This is Glenn Tan speaking. It is an honor to have such a great chance to be with you. This time, we're going to talk about the Curie centrifugal chiller. This presentation divided into these four parts. First, we will talk about the components, and then, based on our Selling centrifugal series, we divided into the CE, which is the fixed speed series, and then the CVE. CVE, it is you can just think that it is the inverter series, and the last is the CC. CC is the magnet suspended inverter series. This is the front view of the Curie centrifugal chiller. Let's recognize the components first. And this one, the black one, the black cylinder, you can also find it. It is the evaporator because it is doing cooling. So the surface always put the insulation. And this one, condenser. No need to put the condenser, just leave it, it's okay. And this is the economizer. This can higher the system efficiency. And this one is the electrical box. It's for the power supply. And this one is the compressor, most important components inside. And this one is the CVE series. So there is an inverter. And inside this one, this is the motor. How this compressor operates rely on this. First, we will talk about the evaporator. Our latest product also adopt this falling fin technology. The falling fin just compare with the floodlit tie. And for the floodlit tie, first I will explain how it works. And you can see this blue area. It is actually the refrigerant, which means we put the liquid refrigerant just inside, and the water, which is the chilled water, just inside the tube. So the refrigerant, if it can absorb heat, which is to cool down the water, then the refrigerant itself will become gas, which flow to upside, then flow into the compressor, and then the water will be chilled down, right? And what's the problem of it is, from this picture, you can find it on the surface of the tube. There, the liquid refrigerant is boiling, and the boiling will always generate the bubbles, right? The bubbles always means the heat transfer resistance will be higher, and this will lower the heat transfer efficiency. And for the falling film is we will collect the liquid refrigerant and spread on the surface of the tubes, and then also the tube inside is also the water. Also it can cool it down, but just like this, you can also find it when we spray on the tube, and then the refrigerant absorb heat and then flow out, which means it will be less bubbles, and less bubble means less heat transfer resistance. And also on the other hand, for the refrigerant charge amount, just compare with the floodlit tie, it will be definitely lower, right? And on our product, we can save up to 35% of the refrigerant. And also for the floodlit tie, you can just consider that it's taking a bus. And for our Curie falling fin technology, it is also it is not a bus, it's just taking a shower, but your foot is still inside the refrigerant. And here I just compare three types of the evaporator, which is the dry tie, flooded tie, and floor filling tie. And for these three, you can find that the refrigerant and the water, which is either is in the tube or inside the shell, is different. So for the first, the dry tie, the water in the shell, the refrigerant inside the tube, right? And also for the flooded tie, the water in the tube, the refrigerant in the shell. And the same, the falling film is the same as the flooded tie. The water in the tube, the refrigerant in the shell. And on the other hand, from the refrigerant in direction, also you can tell that. Just compare the flooded tie and the falling tie. And the refrigerant only flow in at the bottom. And that's why we need to make it to be refrigerant and then accumulate it at this area. Then it will become gas. The refrigerant will flow out into the compressor. And for the falling film, the refrigerant is just in at the upside. It will flow in and spread to the copper tube. Then it will become gas and flow out only from the upside. And also actually the dry tie is obsolete, and the reason is the heat transfer efficiency is not that high. And this tie is the sectional view of the comparison between this dry tie, flooded tie, and falling film tie. So just like what I have right here, for the first generation is dry tie, and because the efficiency is not that high, so we upgrade to the flooded tie. And the features is all pipes is immersed in the liquid refrigerant, and water scale can be cleaned more convenient because the water scale is inside the water side, right? Which is just inside the tube, and that's why you can use the either the mechanical or the chemical methods to clean this water scale is also very easy. And the last is the falling film, and it can save up to, in our grid, up to 35% refrigerant amount, and also almost no bubble generation on the surface of the pipes. This can higher the heat transfer efficiency. And then later we'll go to this condenser. And the condenser, how it works is the refrigerant flow from the upside, and then it becomes the liquid refrigerant and accumulate it here, and from here flow out. And here is the cooling water in and cooling water out. And just pay attention at this area. And also you can find it. This is the vapor, which is the gas refrigerant from the compressor. It will hit this separated portion, and then the oil can be separated, and this can, the efficiency is also very high, up to 99%. And this can also lower the noise, and also inside it is the tube. Also you can also find that the surface is not smooth, which means this can higher the heat transfer efficiency. This is the sectional view of this condenser, and you can find it. The gas refrigerant flow in from here, and then it will impact with this plate to separate the oil, and then the gas will go through these pipes. Actually, inside this pipe, it is the cooling water, which to cool down the gas, and then the gas will become liquid and accumulated at this area, right? And this area will build the subcooler, which is this one. The purpose of this one is to increase the subcooling degree for better the refrigerant later it will get expanded. And then the liquid refrigerant will flow out from here. And this is the Gree centrifugal chiller family. Currently, we have the CE, which is the fixed speed on-off. It is also two stages. And we have the regular and also the high temperature chill water. And next is CVE, and this is the permanent magnet inverter series. That means it can change the operating RPM. For this one, we have cooling oil and heat pump, and also two conditioned ice thermal storage, and also the high temperature series. The last is the CC series. It is the magnet suspended inverter chiller. And this is how we name the centrifugal chiller. And this part is the series name, either the CE, CVE, or CCE. And this number, it is the compressor code. According to different capacity, the code is also different. And this is the evaporator code. And this one is the condenser code, and different combination, and the code also different. And this one is the compressor quantity. Two means there are two compressors. And the last one is the power supply. And before detail introduce our products, and here I'd like to introduce how we can connect the centrifugal chiller to the BNS system. And this one is the touchscreen controller on LV centrifugal chiller, and at the back of it there is an output, and from here it's already output the RS485 signal, and then you can connect to the RS485 converter and then connect to your PC, and this is actually the Modbus protocol. And also you can select the BADnet. For that one you need to select our Gree ME30. From this device, the output will become the BADnet. Also, you can connect to the computer, which is the BNS system. And not only for the centrifugal chiller, and all for our Gree product, from this picture you can find that just rely on this gateway, this ME30, you can connect to this centrifugal chiller, or the screw chiller, or even the modular chiller. This is actually the RS485, and just use this CF159 device. They can combine together, and then to this gateway, then from this gateway to this router, then to the computer, which is the BNS system. So what I mean is you can use this device to control all Gree chillers. This is remote monitoring solution, and in China domestic market, LV chiller, either it is the modular chiller, screw chiller, or the centrifugal chiller, there is this device. This device can transmit the operating data by GPRS or 4G signal, then to this base, and then it can transmit to our Gree G Cloud. Then we can use the computer or the smartphone to access to this one. Then we can collect and see the operating data, right? Then you will understand, or you can get the information immediately. So for overseas market, we don't have the GPRS or 4G, so we can do the revise on the chillers, which is this device, and then transmit the operating data on the Ethernet cable. Then you can just go to a server. Then you can also use the other computer to access to it, or the smartphone to access by the internet. And also you can collect the operating data to immediately get what's wrong or what is the parameter of it. And this chapter is going to introduce the CE fixed speed centrifugal chiller. For the CE fixed speed series, and here is the capacity range, single compressor from 350 to 2030 refrigerant ton. Two compressors is from 2400 to 3000 refrigerant ton. And for the power supply is 3 to 50 Hz, and we have these three options for you. And according to different capacity, you can also find it different capacity. The voltage also it can be different, and the reason is the start-up method. You can select start and delta or directory start, but for this one you need to higher the voltage. And also this is the standard, and here is the optional. And all the products there are AHRI certificate. This is the sectional view of the CE on-off compressor, and from here you can find it. This is the motor, and there are two supporters, which is the bearings, and this is the speed up gear, and also there are two stage, which means two impeller for compress. And here is the suction side. Then after compress, the refrigerant will flow out from here, this hose. And also you can find it. It is a semi-hermetic, which can lower the leakage risk. And also there no need the cool down machine or equipment, because there we use the refrigerant to cool down this motor. This can lower the operating cost. And we also use the PT100 or the PTC to check or to ensure the motor temperature, which is not too hot, not too cold, to ensure the operating efficiency. And as for the startup current, for this one is it is the semi-hermetic, and the startup current is lower than the open tie. And for from the design, there are 20% of the design margin for the motor, which can ensure the reliability for all conditions, which means for the surge it's okay. And what is the two-stage compressor? And here is playing how it works. And you can also find it. Here is the refrigerant out, and then the gas will flow to this condenser. Then it will become the liquid, right? And the liquid will go to this economizer, and from here it will be the flash, which will become the vapor, and this is the gas. Then it will flow to here as the supplement, which is the second compress. And the majority of the refrigerant will flow to the evaporator and doing cooling. After that, this one will become gas and flow to the first stage compressor. Then compress it, and then from here, the first, which is from here, and then the second from here, to join together for the second compressor. And what's the benefit is from this view you can find it, and this is the cooling capacity, evaporation, and this is the condensation, which is according here, and this is the original with the economize off, which means this one, and this is the capacity, and this one is the economize on, which means from here we join here, then we can get this part. Additional of this part is about 5 to 6% for the efficiency higher. And also for this one, we can lower the speed of the impeller, which is the lower the speed of the compressor RPM. This can higher the system reliability. What's the benefit for two-stage impeller is this. First, to achieve the same compressor ratio, the speed of the two-stage is about 30% lower than single stage, and also lower speed leads to less vibration and higher the reliability during operation, right? And on the other hand, lower speed also means lower the noise, and for this one we can lower about 3 to 5 decibel A. And also for the two-stage compressor, we can enlarge the flow angle at outlet of each stage of the impeller, which can widen the surf allowance, which is better for the anti-surge effect and wider operation range. And the next feature is it is a closed-tie impeller. Just like this one, you can find it, it is a closed-tie. And what's the benefit is it can effectively restrain the generation of the inner edge, wider the operation range, and improve the efficiency of the impeller. And also we make a simulation that this can also efficiently increase to above 0.95, and also means the inside flow it can be more even and also more smooth. This can lower the resistance. Next feature is the changeable cross profile. And what is it? That is during the full load condition, this discharge is fully open. And during the part load condition, and you can find it, this one just move direction, and this can lower the discharge area. And what's the benefit is by lower this area, the discharge pressure it can be higher, right? And for this one, we can higher the discharge pressure, which to avoid or to lower the surge potential. And the next is the low viscosity brake diffuser. And for this one, and we just ensure the inside the structure of the impeller. This one, it is more smooth for the refrigerant flow. This can decrease the resistance and also ensure or lower the potential of the surge. Next is oil system. First, I will introduce how the oil flow inside the CE series. And first is from the oil pump. The outlet of it is the hot oil, and then goes through the preheat exchanger to cool it down. Then this oil will go through this filter, and then to the oil tank located here, and then it will separate into two passes. First is to the front, and then the other is to the air, and then go through the motor for lubrication and also for the shaft. And after that, it can also collect some hot heat, and then itself will become the temperature is higher, which become hot and then flow back to the oil tank. It's also built in inside the compressor. And then go to this again. As for the refrigerant, and here is the liquid, and then go through it, it will become hot, which is cool down the oil and become gas. And here and not that part, and also here is the built-in e-heater to ensure the oil temperature to be 48 to 52 degree. This can avoid if it's too cold, it will dissolve too much liquid refrigerant, right? So we need to ensure the temperature of the oil not that cold. And so for this one, first is the oil tank, which is this one. It is built inside the compressor, just between the gears, between this part. And the next is the preheat exchanger to cool down the oil, this part, by the refrigerant. It is external. And the next is this filter. The target is to stop or to filter the particle size more than 5 μm. And the last is talk about the high level oil tank. And for this one, why we need it to put it here is if this centrifugal chiller there is a suddenly power failure, even at that time the oil can be flow into the motor or the gears directly by the gravity, can ensure the oil can ensure the lubrication. And then the next is how we cool down the motor, and also we cool it down by the refrigerant. So, and at these pictures you can also find it. This is the preheat exchanger, and this is the evaporator, this is the condenser. We just get the refrigerant from the button of the condenser, and then just like this, and then the refrigerant will come here and divide it into two passes. And also here there are the EXV. And first analyze this part. It will get expanded and then go into it to cool down the oil, the preheat exchanger. Do you remember that? And then for the other passes, it will just go into the motor. We just spread the refrigerant directly on the motor wire to cool it down, and then the refrigerant itself will become gas and flow back to the evaporator. This is the controller of the CE series. It is touch screen and 12-inch, and also it can store up to 180 days operating data before the crystal malfunction occurs. And for this one, you can also download to the USB, and then you can analyze on your computer. And we also support to connect with the Ethernet cable, and which is here. It is for the BNS, and there are 4 levels for the authoritative design, which means you can easier for you to do the management. You can allow the service people or the maintenance man for different authority. Next is for power supply. According to different capacity, which is this part, and the power supply is a little bit different. And so for the low voltage startup, for this series, you can find it. We just have 2 parts, and this one, and it is connected to the power supply. The power supply, according to different area, this is a little bit different. And for the second part is this, which is to connect to the optional wiring, including the indicators and remote control or the water pump, just like this. Just connect to it so you can allow this centrifugal chiller to control, or it can display the error or the operating data. As for the startup method, you can select the start delta, this is a standard, or you can choose the soft startup method, optional. From this chapter, I'm going to introduce the CVE, which is inverter series. This is the CVE product line gap. We have the single compressor, and capacity is from 250 to 2300 RT, which is this one. And this is the 2 compressor. It is from 2400 to 3000 RT. And this is the power supply. For the 3 phases, we have this one, and for high voltage, it's from 10k volt to 660 volt, and here is the frequency. Also, all CVE series, we have the AHRI certificate. And here is the comparison between the CE and the CVE compressor. And first it is direct driven by high-speed PMS motor. That means for this inside, this is the inverter CVE, this is the CE. For the conventional, here is the motor, this is the speed up gear, and this one there is no speed up gear. It is direct driven this impeller, and which means if there's no impeller, and means no, or we can lower the mechanical loss. This is by 70%. And also, if there's no speed up gear, the compressor size it can be smaller. This is by 60% smaller, and also the weight is not that high, lower 60%, and this can be high efficiency under all conditions. And also, without the speed up gear, the noise, which is basically the mechanical noise, also it can lower by 8 to 10 decibel, and also easier for the structure. And so I just compare the example. So if we need to achieve 10,000 RPM, so for this one, you just need about this, then with the speed up gear. And for the CVE to achieve 10,000 RPM, this is exactly the motor you need to operate at 10,000 RPM. It's very high speed. Next is what is the benefit we can get from we change the RPM of the compressor, and here is it. And this is in the AHRI text condition for the mechanical loss comparison, and this one is the AC motor, which is the on-off CE series, and this one is the CVE inverter. It can change the RPM. So from the mechanical loss is about we can save up to 70% just due to no speed up gear and direct driven. And also for the noise, it can be about 8 decibel lower, just compare with the speed up gear CE series. This is the benefit we can get if we adopt this CVE series. First, it is the first time we apply the large power, high speed PNS motor in the centrifugal chiller. And also, here is the compressor RPM, and here is the system operation efficiency. We always make the system operate at this area, which it is highest in the efficiency. And the next is it is the maximum torque or minimum current with add control, and this can lead to the less damage to the motor. And besides, we optimize the air gap in the magnetic field. This will lead to less harmonious loss. And here is the comparison between the PNS motor and the AC inverter. So you can find it. It is definitely this is higher. And next is the two-stage compression. And for this part, it's the same as the CE, which is also two-stage. And so for this part, which is we can get additional this for the cooling capacity, increase about 5 to 6%. Next is anti-surge technology for this CVE, and as you know that as the compressor RPM it can be changed, which means the discharge pressure also it can be changed, and which means it is not that easy. Just compare with the CE on-off complexer for the anti-surge. And the first three, which is this three, it is from the mechanical, which is from the appearance on the mechanical design, which can ensure the discharge pressure it should be as high as possible, which is the two-stage impeller and also the changeable cross profile and the series impeller design at second stage impeller. And for this one, it is just like we do a relay, we need to ensure the relay should be smooth to lower the resistance, which can higher the discharge pressure. Besides, on the system control, and just like this graph, you can find it according to different load and according to different pressure difference between the suction side and the discharge side. We create the no surge area and surge area, and also there is a transitional area. So if this complexer is during operation, if in this no surge area, it is completely okay. We will not do anything about it. And if it get into this zone, this green line, green area zone, so we need to adjust the parameter, just like increase the compressor RPM to ensure it will leave this zone. This to ensure it will not enter the surge area. As you know that if we enter the surge, it will lead to the current and also the current to be fluctuate a lot and also to damage the complexer. It will be very dangerous. So if we enter this transitional zone area, we will adjust the parameter to make it to leave to avoid the surge. And this is the protection. And during design stage, we already consider all the pressure, including for the sensors and also the pressure and even the water temperature. We also consider about it. So, which means it is a complete control and protection. The next is for the efficiency, and for this, we just take the IPLV and COP, and the orange color is the CVE. So you can find it for the CVE and just compare with the CE, and it is definitely higher in the system operations efficiency. This is how the CVE can adjust the capacity, and on the left side is for the CVE and the right side is for other brands. So for the CVE, for this orange color zone, it is just by the RPM, which is we change the compressor RPM to adjust the capacity. And so you can find it, we can be as low as 25%. And just compare with other brands, is up to 45%. And the second method is adjust the suction impeller, which is the suction band plus the RPM to adjust the capacity. And last is by the bypass plus a bypass methods to adjust the capacity. And next is how we cool down the complexer. As you know that the complexer, if we operate in a high RPM, inside it will generate a lots of the heat. And here is how we cool it down. Inside it, we just inject the refrigerant, and then this is the liquid refrigerant will spray directly on the coils, and then with the evaporated, it can absorb heat, which is doing cooling and cool down the coil. And for the motor itself, it is insulation class H, which is top in the industry. And also spray rotate runner, which is this is for the refrigerant, and inject to get to lower the motor temperature. This can ensure the efficiency. This is the comparison between the compressors of the CE and CVE series. First, for the CE series, the compressor joint, we need to apply the speed up gear for our desired RPM. And for the CVE, it is direct driven. And also, we adopt the PMS motor, which for the efficiency is definitely higher. As for the RPM, for this one, which is for the motor, which at here, the maximum is around 3000. But for the CVE, it is direct driven, which we can reach 30,000 10 times. For the startup methods, as it is on off, so you can use the start data or the soft or direct startup, which means the startup current is higher than the operate current. For the CVE, as we can change the compressor RPM, which is at the beginning, we can make it to be the lowest startup current, and which means the startup current can be less than operate current. Very good for the power supply. And for the capacity adjustment method, we have the suction impeller, which is adjust this suction amount. For the CVE, it can also, besides this one, which adjusts this one, we can also adjust the compressor RPM. And for the startup cabinet, which is similar to the startup method, and start data, soft starter, and high voltage directory. And for the CVE, it is a built-in inverter. Last is for the oil tank. CE is built-in and CVE is external. Next is for the device we use to change the compressor RPM. We apply the IGBT instead of this diode, which is basic or which is common for the regular air conditioner. And for this one, what is the benefit is that the power factor, just compare with this one, is definitely higher. And the most important is the total harmonic deformation rate. It is less than 5%. And for this one, for this diode, it is more than 30%. So with this one, there's no need a power compensator or an harmonic filter. And of course, this is it can be customized. For the inverter drive, either it is IGBT or the diode, it will generate lots of the heat. So for the compressor drive, we need to set up a new device to release this heat to ensure the reliability. And here there are two methods. First is we need to cool down by the refrigerant, just like this, located here. And also you can find it, this is just the heat sink, just a bit high, the driver. And then inside it is the refrigerant. The refrigerant will absorb heat and then it become gas and flow back to the flash tank. Besides, we also have a small size heat exchanger. You can find that this is the small size heat exchanger, and from this one we can also doing the cooling and then use the fan to circulate the air, which is to cool down the electrical box to ensure that it is not overheat. As for the oil system and coolant for the CVE series, here first I will describe how the oil flow in the compressor. This is the oil tank, this is the compressor, and the oil will be pumped out with this oil pump. And after through this filter, it will get to the compressor high level oil tank, and then here it will divide it into mounting and then just offer the oil to the gear and then after lubricated, it will be heating up, right? And then it will become hot, the warm oil, and flow back to the tank. And then we will also use the refrigerant to cool it down. Just instead of the preheat exchanger, we make heat exchange. For this one, we just directly spray the refrigerant into the oil tank, and just like this, which is controlled by a solenoid valve. This liquid is from the condenser, and just after this capillary, and in the actual it will be located here, and then we spray this refrigerant into the oil tank to cool down the oil, and then the refrigerant will become gas and flow to the compressor suction side. And besides, there is an e-heater located here just to ensure the oil temperature between this range to avoid too much liquid refrigerant dissolved in the oil. And also the oil tank, just compare with the CE series, it is external setting, and this filter, the target particle size lower limit is 5 μm. And also we have a high level oil tank just in case if there is suddenly power failure, the oil can be flow into the gear for lubrication by gravity automatically. Next, we will go to the oil return, which is during operation, the oil just flow into the system with the refrigerant, and it will accumulate it at the upper layer of the liquid side at evaporator. The oil return is aimed to circuit code, which is to return this part of the oil to the compressor for lubrication, and the keyword is the injector, which is this device. And actually it's this one and also this one here, and there are two steps. First step is for the injector. Inlet 1 is from the high pressure refrigerant, and then the inlet 2 is from the evaporator, which is mixture of the oil and low pressure refrigerant. If they mix together, it will just become the mixture. And then to the mixture also, on one hand, the refrigerant in the mixture will become gas, which it can absorb heat, and then and to flow out, this can higher the oil concentration. And at step 2, we will conduct another high pressure refrigerant gas to inject, which is to push this mixture to go back to the compressor for lubrication, and which is the target is the oil tank. Then there is an oil pump waiting for it there, so it can pump the oil into the compressor. And this is the oil system comparison between CE and CVE series. So you can find it. I just compare the oil tank. This is built-in and this is external. As for the oil cooler, this adopt the preheat exchanger, and for the CVE, we just spray the refrigerant directly to the oil. For the filter, it's the same, which is target is 5 μm or above. And high level oil tank also the same, which is located at the higher position. And also there is a built-in e-heater to ensure the oil temperature at this range. And this is the controller. And actually for this part is almost the same as the CE series. As for the controller, this is the interface of it. It is a 12-inch and touch screen, and we support English and Chinese. And for this one, it is a cell adaptive control, which is stable output. For this one is just this, and this is the living chill water temperature. And before the optimization, you can find it. The water temperature fluctuate a lot, and for after, you can find it. It will become stable quickly. And also we have different levels for you to do the management, which is convenient. And for this one, we have the soft loading and soft stop, which means we can slowly increase the compressor and also slowly decrease until it completely stops. And for this device, also it can connect to the remote monitor. It's very convenient. Next is for the power supply. For this part, according to the centrifugal chiller, which is the low voltage and high voltage, we divide it into different. And this case is just to display for the low voltage. You can also identify from here. The number 1 is for the power cable for the 3 phases. This is still a low voltage. Just consider it is the centrifugal chiller. And for number 2 is for the external wiring, which is you need to connect to the chill water pump or the cooling water pump, and also the cooling tower fans. And also this is the remote switch to turn on or turn off, and operating status and error indicator. For the next chapter, we will go to the CC, Meganet Suspended Inverter Series. And here is the product line gap. Currently, we have the single compressor only. It is from 100 to 1300 RT, and the pulse price is this one. Also, we have the AHRI certificate. And this is the CC compressor. What is the difference between this and the previous one is that this is the impeller. This part is the same. The motor almost similar. It can change the RPM. What's the difference is this bearing. It is magnet bearing, which means the shaft not touch the bear. For this one, it can definitely lower the friction. And also for this one, we don't need the oil for lubrication as they don't touch together, right? This is the magnet bearing, and this is the sample pictures. This two is the two-stage impeller, and this one is the shaft. This one, and also this one is the bearing. It just generates the magnet to suspend this shaft. And there are 3 main features of it. First is the high precision for this, and the flow tank precision, it can be up to 2 μm. And first we need to do its position. There is a position sensor which it can bear provided up to this RPM in real time with position. And next is the power failure energy feedback. And for this one, once there is a power failure, we will conduct as a power generator, which means once there's a power failure but this shaft still operate, and then we can conduct the wiring, which is for the magnet, make it as a generator. Then it can generate the power, which also to slow down the shaft and to achieve the soft contact to avoid the suddenly boom 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 to damage this bear. And the last is the protective bearing design. That means no magnet material inside of this one. We just generate the magnet by the electric. As for the oil system, just like what I had introduced, as the shaft and the bearing, there is no contact during operation, so no need the oil system. As we don't need it, also we can cancel the oil cooling system, which can definitely simplify the structures. and also no need the oil filter. This can lower the maintenance cost and time. For the maintenance, just compare with the conventional, which is the CE or the CVE series. And so we just compare the first we need to replace the oil, which is including the oil supply, oil return, and oil cooling. And then to check the oil pump and check the oil quality, and also to replace the oil filter. And if there is a performance job, also always due to the oil leakage. For this one, we can also save it. And here is the oil quality density. That means as the system operation, the oil will be deteriorate. So instead for CC, there's no oil, so we can eliminate this potential. Next is for the controller. For this part is completely the same as previous. We just add the CC series related parameter into this controller. And of course, this can be customized for the items. Next is for the power supply. For the CC series, we only support 3 phases, which is this one. And for the wiring, first for the power supply, and then number 2 is for the external. For this part, the same as previous, so we can skip. That's all for the introduction of centrifugal chiller. If you still have any question, just feel free to contact me on this email address. Thank you.